Okay, so today is chapter 4, part 1. We're getting into statistics and metrology. So we use this to control the industrial processes. Again, the stat is for processes. We monitor the processes by using stat most of the time, okay, because it's pretty convenient to do it. So statistical quality control, SQC. We have 4 activities. The very first one is we study the process capability. The second one is SPC, and that's statistical process control. And we deal with the controlling, okay, a particular process, concentrating in a process. And the third one is inspection, okay, and that's completely based on a stat-based sample inspection. And the last one is a design experiment. Again, a stat design experiment. It's all about monitoring. Okay, so basic statistics. So what we do is like every time we have a problem, okay, we choose to solve it by using stat because it's easier to do it so that way. So what we do is first we collect the data, right? And data is nothing but information about the process of your monitoring. And then we compile that data into a table or a graph so we can visualize that process. And then report, okay, the organized data, and we call that the descriptive statistics. So meaning like just like if you want to study the speed of a particular machine in the manufacturing plant, you want to collect the information of the speed of that machine. Okay, you run it day night. Okay, you run it different days, different night, different sets of operators, different sets of management. So you're getting the data of the machine, how it goes, right? Depending on the environment that is in. And you will come up with many different sets of data and you compare them, right? And then we compile these data, prep the data from raw data, okay, and then throw it in a table or a graph, and we take a systematically organize them and look at it so that we know everything about that machine. Also, we know everything about the environment around that machine, okay, whoever using it, or if this group of people use this machine, that's the kind of the result this machine is going to give. So if this set of operators is going to use this machine, this is the result it's going to give. Well, if this management group is going to oversee this machine, this is the type of data we would get. Okay, so that's how we study almost everything in the manufacturing, and then we choose the best, right, for our products, quality of the products, and also where the end result is that we're looking for the best result that will increase the profit, all right, or whatever you're producing. So anyways, it's a systematic study, all right, of something that you're studying, usually a process or a function. Okay, central tendency. So this is a review from your high school probably. I'm not quite sure. Like some of you, I think, haven't taken STAT. Some of you, I believe, you have already taken that either at high school or in university. So anyway, central tendency. Central meaning like something in the middle. So we're dealing with the average, we're dealing with the mean, and we're dealing with something that's typical, right? So you have a group of data, and the data will come in many different ways, right? And what we're looking at is we're looking at the average of all of that. Okay, average is nothing but is a point. Okay, a point that the data. Okay, majority of the data is it's going to be there. Okay? And you also have deviation, okay, from that average or mean. I just write AVG right here for the, so these are all the deviation, okay, from the average. So let's say the data got to be perfect right here, but then when your data is there, you have a deviation that much. Yeah, see that distance from here to here, that's the deviation. So average, mean are something that is typical. These are not typical because it's far away from the typical line. So we have 4 measures in a central tendency. The very first one is the mean, second one is the median, and then mode, and then mid-range. Okay, read this way, mid-range. So these are all measures for central tendency. So if somebody wants you to measure central tendency, okay, you're gonna measure all of that. So you know what's the median or mode, or what's the mid-range, or what's the mean for your data, okay, data set for whatever process you measure. All right, mean. Mean, this is a little bit off, so it's kind of like this. Okay? The mean is x bar. It's just arithmetic mean, commonly known as average. And we have 2 different x. One is a big x for population. We have a little x, okay, for sample. For stat, we're using it for inspection. And all the inspection, okay, come from the product sample, SAMPLE. So therefore, it's automatically, okay, little x, yeah, x bar. So that's the mean. But if you think about high school statistic or universities, okay, stat, you're gonna get confused with the population mean. Population mean is before you sample it out, it also has its own mean, okay? Alright, so again, arithmetic mean, complete math, and we call it average. What are we doing? We sum, alright, of all the values, and then we're going to divide that sum with total number of the value. So here is the equation. It's pretty easy. So that's the mean, x bar. This guy is sum, right? SUM. It's just a Greek symbol. So every time you see that means sum, right? And you're going to add I. We're going to start with 1, go all the way to n number, yeah? So sum it up from 1 to n, yeah? For this data x, okay, x means a data, yeah, whatever. Let's say the height of the student is 5 feet, let's say 5 feet 6, okay? So 5 feet 6 inches, and another guy is going to be like 5 feet 9 inches, 5 feet and 9 inches, so and so. So that's your data, okay? And that is called x, okay? Median, mean is x bar, okay? So anyway, any kind of data. This is just an example height. Alright, so here x and little I mean, I have from here 1 all the way to n, 1, 2, okay, dot, 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 go all the way to n, yeah, number of data, yeah, that many height I'm studying, and divide that sum, okay, so I can draw the whole line right there with a number, that many number, n. So if I say I'm going to study the height of 6 student, this would have been 6, yeah, 6, and I'll be having 6 height value in there, and you're going to line up, and then you're going to add them up, and then divide it by 6, and you will get your mean, okay? Okay. Okay, so let's say a person eats, can eat about, let's say, 4 hamburgers, okay, a day, let's just say. So one can eat 4 hamburgers a day, the next person can eat like 3 hamburgers a day, and the third person can eat only 2. Okay, the fourth person can eat 4. So now I'm dealing with 4 people, yeah. So what is the average that this group can eat? So you add them up. This is 8, 10, 13. 13 divided by 4 is going to be the average that this group can eat. Okay, so that many hamburger that they can eat a day. So all you have to is 13 divided by 4, but they're going to give you about 3, 3 1/4 that they average 3 1/4. Not average of the people can eat, no. Average of this 4 people can eat. Okay, that's 3.24 hamburgers. And if you study what kind of people they are, then you will have types of these people. So this is what we call studying the data. Yeah. So if you put the environmental factor, the type of the people, are they all guys? Are they all girls? Okay, or are they mixed? Yeah. So and so anyway, so you can put many different kinds of factors in that, right? So and link to the number, the average number that they can eat the hamburger. Yeah. So what if like they're all European citizens? They might eat 3.25. What if we're asking for Japanese Japanese citizens to eat burger? They might not eat this one. They might be lower than that, yeah, because they can swallow the hamburger. So anyway, so that's how we study, right? Study the information, whatever you're collecting that way, and then put a different variable to the group of data and see how different they are. Okay, and so getting the average is so important, and this is how you get it. Yeah, it was pretty easy. All right, let's go to the next one. So this is a formal example. We have a set of 5 measurements taken from a sample, 5 shifts, and the values are blah 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 like that. Now we want to get the sample mean. So therefore sample mean is x bar. Sum of I equal to 1 go all the way to n. In this case 1, 2, 3, 4, and 5. Yeah, therefore 1 equal to 1 all the way to n is 1 to 5 right here. Okay, and here's your 5 data sets. So now we're going to add them up. Yeah, so we get this. It's said to please divide it in order for you to get this mean. So we divide by 5. So we get 25.05. Yes. Is your mean measurement. Again, mean of the 5 shifts. Alright. The problem doesn't say what the measurement is, only say the measurement, so it can be something. Okay, next one. We're getting into median, how to calculate median this way. Okay. So median is just a data point, and that occupies the middle position. Yeah. So if you have like a data set, I have my data right there, and we want to know the middle position. Since we're dealing with a position, there has to be a relationship. So therefore the relationship is we're gonna line them up either in descending or ascending. Okay. So let's arrange that. So you have data 1, 2, 3, 4, 5 right there, and you will have to line them up or down that way. So data 1, data 2, data 3, and then data 4. Okay, descending or ascending in whichever way you want to line it. You can line it. And then you're gonna see the middle position of that. Okay, so if I got like 5 of them, the middle position is probably right there, which is this guy. Yeah. Formula. So if you look at the formula, you can see this is written in mathematical expression And how do we calculate it? We calculate this way, yeah. So if you look at it, that's we're getting a median for a data set. And here I have number of that data. We're going to add 1 divided by 2, and you will definitely get median. Yes, that's the number of the data. If you have like a 6 data in a data set, 6 plus 1 divided by 2 will give you the median, which is the middle position. So let's take a look at the example. So my data is this, and I've got 5 in my set. We're going to rank it. So I'm going to arrange it in a descending order. So going 8, 6, 5, 3, 3. Then I'm going to calculate the position. So you can use the math. So I have 5 plus 1 divided by 2, and you will get the position. It's at the third position. Okay. So the position is the third one. So we will go here. This is the first, second, and this is my third. Right? The value of it is 25.05. Okay. I think you get it. So the most important thing is when you get the data set, line it up in either descending or ascending. Okay. Then you will calculate by using the formula. Use a number of the data. Add 1 divided by 2 will give you the position of that median, will give you the median. So median is where? Is here. What is median? So I think based on the last semester, right, I see some of the students, not many, few of them, understanding the median as a value. Median is not a value, okay? It is a position. So don't confused. And position is a place, okay? And at that position, of course, you're gonna have a data, and the value of the data is this. The position is 3, okay? 1, 2, 3, 4, 5. The position is 3. If you go ascending, 1, 2, 3, the same. The position doesn't change whether you descend or ascend. Okay, so therefore, do not think median is a value. It is not a value. It is a position. Okay, it said it so. The middle position. MI, right? DD, LE, middle position. I have to say this because last semester I assumed that when you read it, you get it. Okay, it's not. You're not getting it. You're thinking like median. Maybe you're not reading it. That's why you're not getting it. So you have to read. Median is the middle position. It isn't a value. All right. Median is not 25.05. Median is the third position where you're gonna find 25.05 at that position for this particular data set. Okay. Alright, so I'm gonna go ahead and erase this. Alright, so we're gonna go next one. Second example. We have 4 values. Yeah. It is an even data set. 5 is an odd data set. Even data set. So we're gonna line them up. Descended or ascended doesn't really matter. Okay? Because the position doesn't change. We're going to get the position by using the formula. 4 plus 1 divided by 2 will give you 2.5 position, 2.5 position. So the first, second, and a half position, there's no value at that position. So therefore, in this case, we're going to take the value on this side, and divide it by 2. Yeah. On this side, we have 25.06. On that side, we have 25.03. Okay. Divided by 2 because it said it so. 2.5 position. If the position is 0.5 after 2 and 0.5 before 3. Yeah, third position. So therefore, we get that. Yes. And at that position, you have this value, 25.04. Alright, next one. Next one is called mode. Mode is the value, okay, and this occurs with the greatest frequency. Frequency is just a time, okay, how many times it repeats. So mode is the maximum repeated value, so the most common value. So using the data, we have that data, 5 of them. Yeah, we're gonna rank it. The same thing, rank down or rank up, doesn't really matter. After we rank it, we're gonna look at the frequency. So 25 is the same, so 08 is only 1, 06 1, 05 is 1, 03 is 2. One time, one time, one time, 2 times repeated. So therefore that's the highest frequency. So therefore mode is 25.03. Okay. Okay, here we go. So let's erase this. Alright, the next central tendency is mid-range, and that's midway between the highest and lowest value. And we will use the same data set, 5. We're gonna rank it, okay? Rank down, rank up, doesn't really matter. And here I'm ranking it down. So you can see this better in this way. So you can see that's my highest and that's my lowest. So the mid-range is the one between the highest and the lowest value. So you would take that and put it in, okay? Add it up, divided by 2, and you will get the mid-range, which is 25.05. Okay? So it's not that hard to get the mid-range. Alright, next one is the dispersion. So after we learn central tendency is, okay, it's most of the time in the middle, yeah, of a data set, from mean, mid-range, median, and the mode. Okay, so now we'll get into dispersion. Dispersion is nothing but we're looking at how the data are dispersed, okay, how they spread out. So we look at the range, variance, and the standard deviation, okay, how deviate they are, how varied they are, okay, and where they are. Range is nothing but the data are from here to here, okay. Variance is nothing but how varied they are between each data. Standard deviation is how far away are they, okay, spread around the mean the data are. Okay, so let's take a look at that one by one. The very first one is range. Now how to get it? So the range is the difference, yeah, between the largest and the smallest data in the data set. Equation, okay, we write it this way, range highest minus lowest. We're going to use the same data set, we're going to rank it, get the highest, get the lowest, okay. Range, take the highest minus the lowest, and you will get 0.05, and that is your range. It's not that hard to calculate. Okay, so the second one is your variance. So variance, we write this way, S square, okay, that's your variance. And we use this formula, the stat formula, to get its value. So here it's just trying to tell you, you have a data set, okay, the data set is X, and X, many different X in there, in that data set, okay, and you have a mean, which is x bar for that data set. Okay, mean is nothing but, we already know how to calculate that, the average, okay, of that data set. So variance is nothing but, you see, look at that. This is telling you how far away, okay, a data is from the mean. So it's telling you that this distance, okay. So this x is that much far away from here. That x is this much far away, okay, from the mean. And you can see how far away they are. So, and that is what we call x, okay, minus x bar. Okay. All right, and we're gonna square that. Yes. And then we're gonna add this thing, the whole thing, okay, that many times. Meaning like it's gonna go 1 all the way to 5. So you've got to have 1, okay? You're gonna add it, and you have to have 2, yes. And you have to add it, and then you have to have 3, and so on, so. Okay, that's the top part. And then divided by, if you have 5, let's say 5 data, you go 5 minus 1 for 4. Okay, divide that by 4. So that's what it's saying. Yes, so it's not that hard actually. You should be able to get it, but don't try to memorize it. Okay, there's no need to memorize anything. Just draw in the way I draw, and it should be in there. So you have a difference of your data from the mean, square it, add it to that number of data, divided by that number of data minus 1 is going to be your variance. Okay, you can also use this way. That's the same equation. This and this is the same, but we're writing it by breaking this square. Okay, so we take this out, so that's square. Okay, so if you remember like how to do this, remember in the high school mathematics, so that's a square. Yes, so it has to have 2 of this, remember? Yes, square mean like this. So if you multiply, one of them cancel out, okay? So like that. So this equal to that, yes? So you're gonna multiply this and this, so you will definitely get square, yeah? And then you're gonna multiply this and that, so that is minus, yes? X bar and x. And then you're gonna multiply, first you multiply this and this, and then you multiply this and that, okay? You multiply this and this, and then you multiply this and that, okay? So you will get 2 of this, and then you definitely get that, okay? And that is what we're trying to do right here. And then we get the sum of that, yes, for each one of them, okay? Just mathematics, all right? But in our course, we're not going to teach you, okay, how the mathematical deduction is. It's in any kinds of high school mathematics you can go, or even in our university math book. If you have interest in it, you can go in there and take a look at it. I just want to review a little bit, okay, for the starting point. Anyway, so that's how we deduce from here to here. It can also go backwards, okay, the same thing, but we're not learning mathematics here. So you can either use this formula or this formula, and it will definitely give you a square, okay? And this one go again, I1 to n x squared, okay, minus, and you have I1 to n, okay. This one I'm going to show you, that's the whole, okay, the entire sum, the whole square, and then divided by n, and then divided the whole thing with n minus 1, okay. And make sure this is in a bracket, okay, that's the whole square. So this formula is easier to use than that. So what do we do is you can get x squared from the data, okay, and then we can add all the x and then square it, divided by n, and then do this. So it's more easier to calculate this way than that. If you have a real or big table of data, that's better. If you have just a few data, this is better. So it depends on what type of data set you are minding. Okay. Example 4. So now I have 7 data total. And they want to define the variance. Okay. We already know this is from n is okay 7 because I is equal to 1 all the way to 7. Yeah. 7 data. So first we're gonna get x is this, square it. All you have to square, you get all of that. And we're gonna get a total of that by adding the whole thing in your calculator. Add the whole thing in your Excel, the same thing. Yeah. So that way we can use the formula in the previous slide. So now after adding it up, okay, here this is your sum of x, which is your x, and we add the whole thing, 178, okay, from the table. And then the sum of x squared, we square the x, and then we add it up, okay? So you will get the second column total. Now we go there and put it into here. This is the sum of your x squared, and this is the sum of x, and then square it, okay? So we're gonna put first is the sum of the x squared minus, okay? This is the sum of x, and you put it in and square it, and you will get this number. Okay, this is your 170. So how did you get this one? Is 178 something, okay? And then that is the sum of x, and then you the whole square it. It said it so, yeah, sum of x and then square it. So this one is nothing but the sum of all of your x. Some of us we do okay sum of x and we don't even write this I equal to 1 to n. It's automatically understood. So it's up to you. I usually just go sum of x because we already know that's going 1 to 7 anyway. And you will get your variance this much. Yeah. Alright, next one. Standard deviation is a positive square root of the variance in mathematics. The same thing, you have a data set, and that data set has a mean, which is x bar, and you're again looking at how far they are away from the mean. And here you can see s squared, that's the variance. You square root the variance will give you standard deviation. So standard deviation is the square root of variance. Variance is s squared. When you square root it, you get s. Yeah. So if you want to get standard deviation, all you have to do is square root the variance, and you will get standard deviation, which is s. Same as this, yeah. If you have 4, you get 2. Why? Because 4 is 2 square. Yes, the square root of 2 square is 2. So the square root of s is s. Yeah? That's just a review for your math. Okay, now we will square root the variance formula here, square root the variance formula there. So use the variance calculated in example. So s squared equal to 0.043. Standard deviation. We already know the variance is this. Variance. Put the variance value here, square root it, and you will get 0.21. Okay, so So every time you want to get standard deviation, first you're gonna find, okay, variance with a square, and then use the formula and get the variance. After you get the variance, all you have to do is square root it, and you will get the standard deviation. Okay. Alright, so that's it for chapter 4, first part.